Okay, so I want to go through cofunctions. This was actually in your book, but we didn't get to it in the notes for cofunctions. Okay. If you go back first and look at, let's say, take just a 30 degree, 30, 60, 90. And if you look side opposite, the 30 is 1, the hypotenuse is twice that, and the longer leg is radical 3 times the shorter side. If I said figure the sine of 30 degrees, okay, sine of 30 would be opposite over the hypotenuse, so it would be 1 over 2. If I said figure the cosine of 60 degrees. Now if you look at the 60 degrees and said figure cosine, it would be this adjacent side over the hypotenuse, but the adjacent side is 1 and the hypotenuse is 2. So sine and cosine, they are cofunctions, okay, because you're going to end up at the same answer. Okay, so the cofunctions, the formulas look like this. The sine of, and we're just going to use x. They might use theta, they might use x. Sine of x equals the cosine of 90 minus x. So if I said sine of 70, that would be the same as the cosine of 20. Okay. If I do cosine of x, it's a cofunction with sine of 90 minus x. So if I said cosine of 50, then it's the same as the sine of 40. Okay? Those two are cofunctions. Tangent of x equals cotangent of 90 minus x. And cotangent of x equals tangent of 90 minus x. So tangent and cotangent are cofunctions. Okay, and the last, secant of x and cosecant of 90 minus x. And it works out just because of the way the right triangles are. And cosecant of x equals secant of 90 minus x. So if I said secant of 80 would be the same as cosecant of 10. Okay? They are all cofunctions. Okay? Okay. Now I want to go through when we talk about the graphs, we'll learn all 6 trig graphs without a graphing calculator like we did yesterday. But we're going to actually today look at we will study 4 parts of these graphs: amplitude, period, phase shift, and vertical shift. Okay, and we're actually going to do the amplitude and the period today. So I want to talk about that. Okay. On your calculator, we're going to do some of this on the calculator. First, we're going to look at the graph for y equals the sine of x. Normally we'd say theta, but on the calculator they're going to use x. So, and everything we're doing is in radian mode. Okay, so go to the mode. Change it to radians. Okay. Clear out any equations you have in y sub 1. Okay. Clear out all those. And then type in sine of x. And the calculator puts the parentheses around the first one, so close that off. Y equals the sine of x. Okay, now you can set your window for your x-min and your x-max, but there is a user-friendly window that's zoom trig. Okay, so if you look at on the top row, zoom, you just do zoom and then number 7, zoom trig, zoom 7. Okay, and then you should see the trig graph for y equals the sine of x. So it should start coming through, okay, like that. Okay, that's pretty quick. Now, how do you know it's graphing something? Because you've got a window, and sometimes you put in an equation and nothing shows up. That does not mean it's not graphing. And sometimes you want to see your graph again, okay? Like if I just go back to the y equals, do this with me. If I go back to the y equals, and if I go to graph, the graph is there. I actually want to see it go through again. Okay, to see it go through again, you must go back to the y equals and type over it. You got to type over something, just one part of it. Okay, so go ahead and hit the sign button again. Okay, now, this time when you do graph, hit the enter key. So go ahead and hit graph, let it graph for a little bit, and then hit enter. Okay? The way you tell that it's graphing something, in the upper right hand corner is what they call a worm cursor. Okay? When you hit enter, okay, enter is like a pause key. Okay, so enter. When you hit that key, it's like a pause key. Okay, and in the upper right hand corner, you're going to have this little thing is a worm cursor. Okay, and you might put to see it graph again. Retype over part of it. You just have to type over one thing that's in your equation. Okay, now it's paused. You can see the worm cursor just kind of sitting there. Okay, you can press enter again, press enter again, press enter again. It will pause every time you press enter and then start, Okay. Now if I go back to the y equals, okay, and I want to see it graph again, so type over the sign or the x, retype over something. This time, when you hit the graph, press the on key. Okay, so let it graph, and this time, press the on key. Now you'll notice the worm cursor is gone. The on key is like a break. Sometimes, not so much in Trig, but sometimes in Calc, we're graphing something and it's like, okay, this is taking forever, and I know it's wrong, and I don't want to sit here while it goes through it. Okay, so the on key is like a break. That totally breaks the graph and allows you to start over or do something else. Okay, so and probably we need to put to see it graph again. Retype over something. Okay, this is that's the user-friendly Trig window. And if you go to the window, okay, normally on the Trig window, when we're looking at the x-min and the x-max, when we look at our window and we did our graphs, we went like -2 pi to 2 pi, and we went -1 to 1. But if you look at this, it is not -2 pi. Okay, it's negative, because -2 pi would be about -6.28. Okay, so it's close. Okay, it's because of the pixels. Okay, the 1.57 for x scale, that's like pi over 2. So if you can use your pi key, if you type in pi divided by 2 for x scale, that's where the 1.57 is coming from. Okay, and notice it's going from -4, so this is actually -4 to 4. So it's the graph's gonna go like -1 to 1. Okay, so when you graph it again, watch it go through, and you can see it starts at 0. Okay, at pi over 2, it's up to 1. Pi, it's down to 0. And here's our -1. Okay, so you can see it graph. Okay. Okay, so that's the regular sine graph. Okay, now we're going to talk about amplitude and the period. Let's do amplitude first. Okay. For the amplitude, if they give you the graph, if they give you the picture, if they give you the graph, you use this formula for the amplitude. Amplitude equals 1/2 the maximum, and that means the maximum y value minus the minimum. Okay? So it's the maximum y value minus the minimum. So the uppercase m is the max, and the lowercase m is the minimum y value. So if I gave you a graph, if I just made up a graph, I'm making up one, and let's say, I'll do this. Let's say this y value was -3, and let's say this y value up here was 4. Okay, then I'd have the amplitude equals 1/2 the 4 minus a -3, so it'd be half of 7, which would be 7 halves or 3.5. I'm right at 3.5 or 7 halves, either way. So picture-wise, you can just take 1/2. That is the main formula for the amplitude, if they give you the graph. Okay, and the amplitude, what does that refer to? I can change the amplitude of my voice, or I can change the amplitude of my voice. And what that does to your graph, you've seen it when my graph comes up here, and you're seeing the amplitude. Okay, you change the amplitude of your voice. Okay. Okay. If they don't give you the graph, how do you tell? Okay, on a little table here. If I give you y equals the sine of x, and if I took on the regular sine graph, if I took and figured the amplitude, 1/2 the maximum minus the minimum, and on the regular sine graph, the maximum y value is 1, the minimum y value is -1, so half of 2 would be 1. So the amplitude of this equation is 1. Okay? Now I'm going to draw a little separator. Say I give you this as an equation. What happens if we put a number in front of the sine of x? Okay? So do that on your calculator. Go to the y equals. You can do second function insert. Remember, the insert key is right above the delete key. You can insert a 2 in front, or you can retype it. Okay, and then graph it. And we could actually go in and find the max. You can do second function calculate max. Have we done that? Do you guys know how to do that? Let's do it in here. Do it right above the trace key. Second function calculate. And go to max. And I'm going to find the one at pi/2. So it looks like it's 2, but just to check it, get it to the left of the maximum point and press enter. Okay, and it should mark it with a triangle. Get it to the right of the maximum point and press enter. Yes, just press enter. Okay, and there's your maximum y value. Okay, and this is the pi/2. Okay, so maximum is 2, and if you did the minimum, it'd be -2. So half of 4 would be 2. So the amplitude for this equation is 2. Okay. Let's do another one. If I said y equals, what happens if I make it a -2? Okay, so on your calculator, insert a negative sign. Make sure it's a negative, not a minus sign. Okay, and then graph it. What effect did that negative sign have on the graph? Yeah, it reflected it about the x-axis, right? Instead of it starting at the 0 and going up, it's starting at 0 and going down. But the max is still 2. The minimum is still -2. So the amplitude of this one is still 2. Okay? Let's do one more. Y equals, what happens if I have a half sine x. Now, if you put that in as a fraction, I would put it in as 1 divided by 2, or you can put in 0.5. So let's just put in 0.5 sine of x. Okay, and graph that. Okay, and now the maximum point is a half. The minimum point is a negative 1/2. So 1/2 minus a negative 1/2 would just be 1, and a half of 1 would just be a half. Okay. So what I want you to see is the amplitude. If they don't give you the graph, and if you don't have a calculator, you can figure the amplitude by looking at the number in front, except for this one. So the amplitude has to be the absolute value. It's got to be the absolute value of the number in front. So main equation there is y equals, use a lowercase a for the amplitude, and then sine of x. Okay, and the amplitude equals the absolute value of a. It's the absolute value of that number in front. Okay, it is the same for sine or cosine. So if I went back in and I changed these to cosines, okay, I still use the same formulas for amplitude. It's the absolute value of the number in front. Okay, so if I said, as an example, if I said y equals negative 5 cosine of x, okay, it's the absolute value of the number in front, so the amplitude is 5. Okay, okay, that's amplitude. Now let's do the period. Okay. Let's. Okay. On these, when you look at the graphs, okay, the period is when the graph is ready to repeat. So you basically pick a y value and see if it's going up or down, and when is it at that point again. Okay. Do another little table. Let's look at the graph and the period. For y equals the sine of x. Okay. Go back to that. Clear out your equation or delete that. Okay, and graph y equals the sine of x. So if you look at the origin, the graph starts, the y value is 0 and going up. When is it 0 and going up again? Should be at 2 pi. So the regular sine graph repeats every 2 pi. Okay, now let's change the equation. What happens if I put a 2 in front of the x? Okay, so go back and you can insert a 2 in front of the x. Graph it. Okay. Now, this might be one where you want to see it again. Okay, so go back, just type over something. Okay, and you may want to press the enter. Okay, so this was pi over 2. This was pi, 3 pi over 2. Okay, so it starts at the origin, goes up. When is it at 0 and going up again? When is that? Every pi, right? So on this one, it repeats every pi. Okay. What happens if we have y equals the sine of half x, or let's do 0.5 x? Okay. We'll go back. And notice what this does. When you change the period of the graph, you're actually doing a horizontal on this one. Like you basically take the sine graph and do a horizontal shrink. Right? You're squishing it together. Okay. Now go back in and change to sine of 0.5 x. Okay, and this one, you need to look at all the way out to the negative 2 pi. It's at 0 and going down. When is it at 0 and going down again? Over here at 2 pi. So when does it repeat? Every 4 pi. Okay, and that one actually takes, because that graph actually takes it and really stretches it out. Okay, so that one is a horizontal stretch. Okay, you did some of those with the absolute value graphs in Algebra 2, right? With the V graphs in Algebra 2, horizontal stretch and shrink. Okay. Last one on this. Let's say we have y equals the sine of a negative 2x. Okay. All right. Change negative 2x and graph it. What effect did that negative sign have? It reflected it about the x-axis again. And when does it repeat? If it starts at 0 and it's going down, when is it at 0 and going down again? At pi, right? Okay, it repeats every pi. And that one's another horizontal shrink. Okay? So now, if they give you the graph, you can look at the graph and say, when does it repeat? If they give you the equation, okay, and you don't have a graphing calculator, here's the formula. Okay? For y equals a sine. Now, for this one, use an uppercase b. You could use a lowercase b, but they look too much like 6s. So, okay, like y equals a sine of bx, or this is also true for y equals a cosine of bx. Okay, the period of the graph, and they just use p equals, it's 2 pi over the absolute value of b. So if you go back up here and look at these, okay, here, if you look, the b value was 1. So 2 pi over the absolute value of 1 is just 2 pi. Here it's 2. So it would be 2 pi over the absolute value of 2 would just be pi. On this one, it's a fraction, so it's 2 pi. If you said 2 pi over the absolute value of 1/2 would just be 1/2. If you invert that and multiply, you got to go 2 pi times 2 over 1, just be 4 pi. That's where the 4 pi comes from. Okay, and notice the absolute value gets rid of that negative sign. So this is the main formula. Now you should be able to look at an equation and say, what's the amplitude and what's the period of the graph? Okay, so if I gave you an equation, let's say I give you an equation, y equals negative 3 sine of, let's go 8x. Okay, what's the amplitude of that graph? 3. And usually for here, like I just usually say amplitude is the absolute value of negative 3, it would be 3. So your final answer is 3. And the period is 2 pi. Now, you need to write these equations down and get used to them, because they are not the same for the other trig functions. So you need to get used to them. 2 pi over the absolute value of b. So 2 pi over the absolute value of 8. So it would just be pi over 4. Reduce your fractions all the way down. Okay? Good enough? Okay.